We started, yeah.
Can I start now?
Yeah, we are live déjà. So, hello everyone, and welcome to Build with AI series organized by Jede Jesus. We are excited to begin this journey with our first session, part of series designed to explore practical and impactful AI topics. Today we are honored to welcome Sara El-Ateif, our Google developer expert in AI, who will share her expertise thought this workshop. So, welcome, Sarah. The stage is yours.
Thank you very much, Ella. It's a pleasure to be here. So,
Thank you.
I believe the organizers already told you to go over the Building a Multi-Agent System workshop before the actual workshop of today. But I will take the time to actually just explain what kind of like actually is to be done in building a multi-agent system workshop first, before we kind of like go over the actual kind of like rigorous evaluation workshop of these agents. So first things first, what is an agent, right? So practically, like we're human usually beings, but we have like each one of us has a specific role. When in a huge project, we have the designers, we have the front end developers, back end developers, we have people that actually do kind of like project management, and then there's product management, and then there's marketers. So there are kind of like different people with different hats working specifically on a specific task. So obviously we can do the same task as using one agent, right? One person can do everything, but they won't do it as well as if we have different specialists, because beings cannot actually obviously kind of like take over all kind of information at the same time and be good at everything. That is impossible. Although obviously with AI, we can overwhelm it with with kind of like data and kind of like anything that we already know, kind of like in the learning aspect from the knowledge perspective. But the problem is it won't be able to deliver as good of a result as if we had it actually specialize on one thing and kind of like provide us the best service in that one thing. And obviously, even if we want to fix the issues that it has in a specific area, it becomes much more harder for us AI developers to do so, because when we fix something, we kind of like end up breaking some other components of the system. And this is why we have something called agentic AI or multi-agent systems, right? So in multi-agent systems, they replicate the same behavior as one agent, but we have each agent specializing in something specific, and then we have one agent that takes care of kind of like managing all of these other agents so that they can do their job the right way. So in this example of building a multi-agent system workshop, what they actually kind of like walk us through is a content creator system, or sorry, a course creation system. So practically what this course creation system consists of is three specialized agents, and then one, let's call them one project manager, if you want to call it, replicate it, kind of like with human beings. We call it the orchestrator agent. So let's look at the other agents. We have the researcher agent. In this example, what the researcher agent will be doing is kind of like retrieving what you want to build the course around. Do you want the course to be around machine learning? Do you want it to be around, I don't know, UX, UI? What do you want the course to be about? And then it takes this information and goes out there using Google search, the tool. You can use any other tool, Bing search or anything like that, to kind of like find up-to-date information about the subjects that you requested to search about. Then we have something called the judge agent. So, when we humans write a piece of work, that might be kind of like our reports, a blog post, whatever we do, whatever work we do, we have the tendency to go over it, right? Or give it to someone to review it, to see if we have done a good job. Did we do the actual job requested, right? So this is the actual job of the judge agent. It's going to criticize the research for quality and completeness. So obviously it can deliver us with a high quality information of this for this course. And then we have the last agent that is going to be the one to actually build the course, that we call the content builder agent, that is going to turn the research into a structured course. And then we have the orchestrator agent that is going to manage the workflows and communication between these different specialists, okay? So the judge agent, what is it going to specifically do? It's going to either tell us whatever information we have retrieved as research agent is relevant, not relevant, still needs to work on it. So if it's relevant, it's good, it has everything we need. The judge agent is going to give us the pass card, right? And after it gives us the pass card, it's going obviously directly to the orchestrator agent, and then the orchestrator agent is going to be the one to provide the researcher information to the content builder agent so it can actually build the course. So the judge agent doesn't kind of like communicate with anyone directly, and with any obviously of these agents directly. So what you're going to do in this workshop specifically is define a tool using agent, that is the researcher agent that can search the web using the Google search, implement structured output with Pydantic for the judge. So why are we implementing structured output? Why aren't we just processing the test as it is, right? These are LLMs, generative AI. They can definitely do that. They don't need us to structure anything for them. Well, if you want the agent to do the work, kind of like efficiently, that is faster, with a higher quality, the more you can provide it directly with the information it needs to look at, quickly assess it, obviously, the better it is. That's why we implement structured output, and because obviously we can. Then we will connect to remote agents using what we call the agent-to-agent protocol, the A2A protocol. I believe you might have heard of it, especially if you have been going through agents. There is the MCP, A2A, lots of frameworks. But this one, actually, its main role is very simple. This protocol enables this communication. It's kind of like tells you this agent lives at this address, and if you want to communicate with it, here is the URL address that you can use to contact it, right? Directly. So you kind of like don't need to search for, I don't know, different addresses, or searching the code for where the agent is kind of like written in the function or anything like that, if you're kind of like doing the static approach. The agent-to-agent tells you directly, if you want this information, retrieve it using this URL. Obviously, you can use API, you can use any kind of concept to then send the information. Then you have something called a loop agent that is going to create a feedback loop between the researcher and judge. So, when you're given feedback, usually when we humans receive feedback, you have, the first feedback, second feedback, third feedback, until the person that, if you're publishing a book, say the editor is happy with the version that you're providing them for it to be ready to publish. So this is actually what we're trying to replicate using the loop agent. As long as the judge isn't happy or doesn't give us the pass card, the actual researcher agent needs to keep improving, kind of like its research. And obviously, you can limit the number of trials for this, or the number of times the feedback loop can run to 3, 4 times. Here, they limit it to 3. Then you run the distributed system locally using the ADK, the Agent Development Kit. It's kind of like let's call it a framework, or a bunch of libraries that helps make it easier for us to develop agents without having to, go through all the headache of how do we communicate with this agent? How do we link these different agents? How do we kind of like call the tools? We need to write the code for this. We need code for that. So it's kind of like a very quick way, kind of like, TensorFlow or Keras, more specifically Keras, makes it much easier for us to develop, kind of like deep learning algorithms and even machine learning algorithms faster using one line of code instead of 100 or less, because of the complicated components. So that's how kind of like ADK does. It helps spin up quickly all the things we need, libraries and tools and etc., that we might need for agents, so we can quickly spin up those agents and actually just focus on prompt engineering, the simple communication and things like that, and tools to use. So here we use it to run the distributed system locally, so we can test if everything is working, if every agent is doing its actual job as it should. Is it working? Is it reachable? And things like that. And then last but not least, we deploy the multi-agent system to Google Cloud Run directly. As you might know, Google Cloud Run is like kind of like the most easiest way to deploy anything related to Google Cloud services in the fastest way possible. So let's talk now about our actual workshop, today's workshop. So we spun up this amazing course creation application, right? It's working, everything's looking good. We tried a couple of tests. We tried creating a course 3 or 4, and this thing, when we tried, kind of like manually, is what we call vibe checks. What did we do? It's like, let's say, for example, you want to know if an agent is doing its work or not. We, kind of like fill in a prompt or give it a simple kind of like use cases to go over. It's like when we're checking if the type of a certain variable checks or not. We were just giving it a couple of examples. The problem with this is that, and this is actually true even for traditional, known AI programming, we end up missing edge cases. In usual programming, we have something called stress testing, something that usually very few engineers know about. Actually, only engineers that truly work actually on critical systems know about this stress testing methodology, where you're actually pushing the functions to the edge of their edges, right? To cover normally cases that you would never hear of, right? Perhaps something related to the system or anything like that. So vibe checks are just kind of like a lame way that we use, yes, lazy people, that we use to check if the system is doing its work. But it's not the most laziest thing we can do, right? Because being lazy means you're optimizing your time and optimizing resources you have. So vibe checks are actually a non-lazy way to check if an agent is doing its work. So what should we do, right? We need something that is data-driven. We need something that is funded in logic. We need something that will help us test all the possible cases, the ones that we can think of and the ones that we cannot think of, but our users will most likely be going through for this system. And this is why we're going to see today an actual automated way to do that using what we call a GenAI evaluation service that has 2 actual methodologies to do that. Let me move forward as they detail that here. Okay, cool. So these 2 kinds of assessments are the offline experimentation and the continuous evaluation with the automated regression testing. Please, for both of these methodologies, do not think you can use one without using the other. It is best to use both of them at the same time. So what is offline experimentation? So it's actually a process of optimization. It's kind of open-ended and variable, where we actively change inputs like prompts, models, and parameters, so we can maximize a score or solve for a specific problem. Let's say, for example, I don't know, you're developing a solution that has AI that solves mathematical equations or something like that. You would have a couple of mathematical equations with their kind of like result, already available. That is what we will be calling the ground truth, right? And then the prompt is like kind of like the equation. So you will be doing something like this. You're checking using your actual golden, golden truth data set, your actual response, the original one. So the goal for this offline experimentation is to raise the ceiling of what the agent can do by putting it through different situations based on answers we humans already have gone through. But let's say this doesn't obviously cover everything, because there are some things that we humans have not thought of that our users might do. I don't know, spin up different equations at the same time, right? Chaining equations or something like this that we did not account for. So what do we do about these edge cases? These cases that are not covered in our code. So there is something we call continuous evaluation, and it's actually kind of like an adaptive way to fit in the situation. We will be developing tests related to the current context that we have. So this is kind of like not generic evaluations like metrics that we know, bleu, rouge, etc. These are specific metrics that we know of in NLP and we test against. So these are great. These are logic-driven, hard tests, but they don't cover everything, and they don't account for context. They don't account for a lot of variables that might break the system. So the continuous evaluation or automated regression testing is a process of verification. It is a rigid and repetitive. So we hold the inputs constant, like the golden data tests, to ensure the outputs remain stable. The goal is to prevent the floor of performance from collapsing. So this is kind of like the second way. There is actually another way that Vertex AI GenAI evaluation service introduces. It's the one I was speaking about, and it is this one, rubric-based metrics, where actually what we do is kind of like give the LLM different prompts, but it's not us who generate these prompts. You can kind of like code another agent that will be kind of like generating rubric specific to that actual prompt test parameters, right? So it's called rubric-based metrics. It incorporates LLMs into evaluation workflows. It has adaptive rubrics, the ones that fit in based on context and the prompts. They are dynamic. They change based on the prompts, and responses are evaluated with granular explainable pass or fail feedback specific to this prompt. And we have static rubrics. Even in this state, we have static rubrics. Remember that it is best not to remove anything related to the statics, because they also help us test some kind of, let's say, the basic working of the system. So this is for edge cases, adaptive rubrics, and then static rubrics is kind of like for the normal, kind of like working of a certain LLM. So these rubrics are defined explicitly, and the same rubric applies to all prompts. So it's kind of like a standard way to evaluate our system. So responses are evaluated with the same set of numerical scoring-based evaluators, either using bleu or rouge parameters. Obviously, you can use computation-based metrics. Apart from the ones generated in rubric-based metrics, generated by Vertex AI GenAI evaluation service. This is where you will be finding something like bleu and rouge, because they already have been kind of like in the field since the transformers. So they are well known, so we just reuse them as they are. They are deterministic algorithms that we kind of like usually use ground truth, and it provides us with numerous score around kind of like shows us 0.0, 1.0 per prompt. And when ground truth is available and can be matched with the deterministic method. And then obviously there is the third way. I don't know, you have your own way of doing things. If you want something specific, you want something custom based on your own domain expertise or something like that, you can use the custom function metrics that define your own metric through a Python function. It can be anything. So specific metrics that are used in this workshop is the final response match that is reference-based. So in example, does the answer match our golden answer? We have a specific answer. So we're going to kind of like assess if it's closer, if it's far from that or not. Tool use quality, so reference free. Did the agent use relevant tools in a proper way? Did it call Google search when it should have called Google search and it didn't call something else, right? Or just called it for the heck of it. Hallucination, so reference free as well, are the claims in the response reported by the retrieved context. So is the information provided to us? Do we have a resource or references from where it, kind of like we retrieved it from, or did we just come up with it out of nowhere? Then there is the tool trajectory precision and tool trajectory recall. This one is reference-based. So it's something like, did the agent select the right tool and provide valid arguments? And unlike tool use quality, like, assessing if we use the right tool the right way, these custom metrics, as in tool trajectory precision and tool trajectory recall, they are custom metrics. They use reference trajectory as sequence of expected tools, calls, and arguments. So we call a tool X based on context Y because we needed this and we needed that, things like this. So we didn't call it just because we can, but we called it because we needed it and because we couldn't call something else. It wouldn't have actually made sense. All right, so for this workshop, as for the other workshops, it's straightforward when it comes to how to run it and how to actually kind of like spin up the, kind of like develop everything. There is one problem I would like to bring to bring to your attention. Everything until up to this section here works. But the problem is that when you will be running evaluate.sh, there is going to be a lot of issues, okay? So that's why actually I'm not going to run the workshop for you guys today because I still haven't figured out how to kind of like fix the issue. I fix one issue and then I have another issue popping up, still having some frustrating issues with it. But the most important thing is, let me just kind of like tell you just what kind of issues there are so you know about them in case you run this in your own kind of like either laptop or obviously on Google Cloud. So in here, in this evaluate.sh, I believe there might have been some changes in the actual evaluation function. Which evaluation function am I talking about? Let me... okay, we don't have the evaluation function here. You will be finding it in the actual... yeah, in the actual project. All right, let me just open my Google Console so I can show it to you. So you kind of like know about it. Yes, authorize. Okay. Let's give it some time. All right. Let's wait for a little bit. So meanwhile, like I said, there are going to be the first error you will be getting is related to the metrics.name. And then when you fix this, when you figure out how to fix this, there's going to be a problem around access. And the problem around access, and this is actually something that I have encountered not in just this project. Every time I have to do something related to deployment and then Google Cloud, I have this issue with them. I mean, I really don't know why they haven't fixed it yet. I don't even know how they make their own codes work because of these errors, but whatever. Okay, let me just find the function. Yeah, it's this evaluate.py. All right, so I actually changed I changed the code, but let me just find it. It was in 230, where is it? So you can pay attention to it. Okay, yeah, it's this part of the section. Obviously, this is not the code they had. This is the fix. So there is actually a problem in this section around the metrics. So usually what you're retrieving is something called metrics. What they had in the original code is called something metric.name, but there is no metric.name, at least in the new library. So I believe they might have changed something around libraries. And as I said, when you fix this issue and it works, there is a problem around authorization, kind of like what level of authorization can you provide the project so it can run. You will have issues around creating the bucket, the cloud bucket, so you can store your the results. And when you actually fix that, you will have issues around, like I said, specific access rights given to the function so it can store other information. Anyway, one problem will lead to another. This project still needs a fix. So, but this doesn't mean that we cannot learn from it, right? That's why I actually really wanted to go over this workshop, even though it doesn't work. Let me share my laptop. Seems like I stopped sharing. Because it's really, I really loved kind of like the methodology, because it's very interesting. And one of the most interesting things is more specifically the fact that you can actually do all of this validation for different models. So let me just, obviously here, so if you can make it work, kind of like the evaluation can make it work, what you can do here is kind of like visualize the checks, right? When did the agents fail? When did they actually succeed? And this is what I really want to spend some time to go over, okay? So let me just go back and find the Vertex AI GenAI evaluation service so I can show you some really cool examples. Okay, so this is one of the very basic examples that you have here, okay? The GenAI evaluation service features. As you can see, these are what we call kind of like static, basic evaluations you can do. So for example, here, these are what we call criteria. So we have criteria or metrics or rubrics around responses in English. Summary is structured into exactly, for example, 3 paragraphs. Each paragraph of the summary contains exactly 4 sentences. And this actually is what you can adapt. So this is what will be changing depending on the actual prompt. Let me give you some concrete examples by actually opening the collabs. Data set is the ground truth. It's not what the AI generates, right? So software technical debt is like you're rushing to plant a garden, develop software features. Okay, so this is first example. Second example is completely different from the first prompt. Second prompt is around writing a function, Python function, more specifically the Fibonacci number using recursion with memorization, but without using any imports. Third example is around writing a poem about a lonely robot. So on and so forth. So what is really amazing about this new evaluation, let's call it library, is that it adapts based on the prompt. So as you can see, remember what was the request for the first, prompt? To explain software technical depth using a concise analogy of planting a garden, right? So as you can see here, so this is the summary metrics, just general quality in general of the model. As you can see here, we have the mean score, and then we have the standard deviation. So what the model is going to do for adaptive is going to create rubrics specific for this explained software technical depth using a concise analogy for planting a garden. So the first one is this lame one, the response is in English. It passes, as you can see. This is reasoning. It even tells you what made it say this passes. So they say the entire response is written in the English language. So for the general quality V1, it's 100. It passes all the tests. The second one is related to actually explaining the concept of technical debt. And as you can see, this is the only prompt that has technical debt, right? So it created a new rubric around, does the response explains the concept of technical debt? True, yes, it does. The response defines technical debt within the analogy and explains its implications and resolution. And then it created another one around the response is concise. Does the analogy effectively illustrates and actually maps to the concept of technical debt, obviously related to planting trees or whatever, garden analogy? It does. So these are, let's look at the second case. That is case 1 for the writing a Python function to find the Fibonacci number. Let's go down. Well, the lame one is still the lame one. The response is in English. Then let's check out the specific ones, right? So this is the rubric for the function calculates the nth Fibonacci number. As you can see, it adapted to the actual prompt. It didn't give us a general rubric to test against. General rubric might be something like the response is in English. Is it logical or not? This is very generic. But something very personalized is something like the function calculates the nth Fibonacci number, which has nothing to do, for example, with the second case that is related around the poem. And then for the poem, we have something like the poem's theme or subject is a lonely rabbit or not. So things like that. And this is really like the really cool part about this. Now let's see let's call it the third cool part about all of this. It's the continuous integration and deployment. So the really cool part about this amazing kind of like, evaluation thing is that you can actually, let me see where they explain it so you can just like refer to it later on. Yes, I believe it's this one, at least one of it is here. And then understanding safe employment. Yes, this one as well. So please do check this one and then the understanding the evaluation, the implement the evaluation script. So they have something that we call the shadow deployments. So what does that mean? Normally, if you want to test a code in general, right, what do? We should deploy it in a kind of like, let's call it a sandbox or, kind of like similar environment that replicates the actual the actual production environment that we have. But actually what they do in here, it's very similar. They just have something we call revision tags, so that, and kind of like they deploy the agents. The agents are tested in this environment. This environment isn't related to the actual deployed environment, the ones that our users are using and playing around with. It's just kind of like a quietly kind of like living environment in the background that has the same settings, same parameters, tests the new agents. If they do their work well, everything is good. They start then actually pushing the new stream, kind of like the new prompts, the new kind of like requests from the real users directly to the system. But if it doesn't, then it's fine. You can obviously still work on your own agents and improve them without affecting the actual deployed kind of like deployed system that everyone is using in production. So this is really why it's so cool. It's called shadow deployment. So practically every time you deploy, a new immutable version is created, and then you can assign tags to these revisions to access them via specific URL, even if they are receiving 0% of public traffic. So they use that, obviously, they use the CI/CD workflow, deploy, access, and then promote. So the first one is commit, you change the agent's prompt and then push to the repository. Second, you deploy, that is hidden. Remember, it's shadow deployment. No one can see it, only you and developers can see it. It triggers deployment of a new revision tagged with the commit hash. This revision receives 0% of public traffic, so nothing doesn't receive the traffic from the actual deployed app. Only whatever you're going to send it yourself for evaluation. Then third step is evaluate. So this is the evaluation script, targets the specific revision URL, the one that has a problem here. And then the promote, if and only if the evaluation passes and other testers succeed, it's only then that you can actually migrate traffic to this new revision. Otherwise, you can do what we call a rollback. If it fails, users never saw the bird version, and you can simply ignore or delete the bird revision, obviously, just work further to improve it. So that's it for kind of like all the concepts around this workshop. And I hope you kind of like got how this can be useful to us, and obviously how you can use it later on in your own projects, instead of just having to go figure out the different prompts or build an evaluation data set only and hope it will actually work in real world with real users. So that's it from my side. If you have any questions, please feel free to ask them. All right, let me share with you the workshop. I forgot. No, this one. Okay, this one. Introduction. Here is the workshop. No questions? Thank you, Steve.
Thank you, Sarah.
You're welcome, Anna.
Thank you so much for your amazing session. Thank you all for joining us for today's sessions. So we don't have questions, I think.
Mm-hmm.
I want to say stay tuned for our upcoming sessions in World of AI. It was really amazing session. Thank you for your efforts. Thank you so much, Sarah.
You're welcome, dear.
Thank you.
All right. See you. Take care. And thank you.
Thank you, Sarah.
Thank you.
You're welcome to all of you. Thank you.
Thank you.